Hi everyone, welcome to my YouTube channel. This is my first tutorial on solving the lead code problems. So, let me tell you about the lead code platform. This lead code platform is a beginner friendly for solving and for the beginners to learn and understand the DSA topics clearly. Right? So, I'm going to start with the heap or priority group problem today. Because it is easy to start and it's so beginner friendly, and I'm going to use this first problem. I'm not going to solve this in the lead code platform because it is a waste of time for me, because I can run it in the lead code platform itself as we do. Okay, let's start with the kth largest element in history. Now let's read the description of this question. You are part of a university admission office and need to keep track of the kth highest score from applicants in real time. This helps to determine the cutoff marks for interviews and admissions dynamically as new applicants submit their scores. You are asked to implement a class which for given integer k, right, k, maintains a stream of test scores and continuously returns the kth largest test score after new score has been submitted. More specifically, we are looking for the kth highest score in the sorted list of all scores. Okay, I'm getting it. The kth largest elements, we are given to implement these above. We are given a constructor and a method. Constructor is kth largest with the two parameters, and add as a method. Now let's look into the topics we are given to solve. Tree design, binary search tree, heap, binary tree, data stream. Okay, I'm going to use the tree, design and heap. Basically heap is a tree. Okay, heap is a complete binary tree. To talk about, I will tell you deep in the dry run about it. Okay, now let's go to the test case where the kth largest add. These are just the commands we are going to use, like initialization, and I'm going to implement the program like you like. Okay, I'm going to use my own method, but guys, if you like, you can try to implement your own. Okay, I think the priority queue is easy to implement. Basically heap is a priority queue. Okay, this 3 is for this ad, this 5 is for this ad, this 10 is for this ad, this 9 is for this ad, this 4 is for this ad. This is the kth largest value and the array we are going to initialize at first. Okay, let's begin with the code. We are going to use priority queue from Java. Priority queue integer point pass integer values. I'm going to name it as queue new priority queue, and we are going to declare the variable k. Okay, now we are going to implement the constructor. Okay, we need to know about the oops concept to solve this problem. Okay, like constructors, passing arguments, arguments, like that. Okay, now we are going to create an instance for the k. Dot k is equal to k. Okay, sorry. If we are going to pass values into this queues, q dot offer function. This q dot offer function is used to add values like all we use in the queue. Okay, and we are going to use the while loop for checking if the value of size is greater than the kth value we are provided, like basically in the test case 3. Okay, We are going to only have 3 elements in the queue. Okay, now let's use poll function. Poll function, if it is exceeds a value, does exceeds a value, like when we are using this method. Okay, we are going to add the value. Now we are going to use the while loop for, okay, why should we use that? I'm just going to copy from this line of code and paste it in here, and we are going to return the head. Okay, heap function, sure it will work. Let's run this code. What the hell? Shit. Sorry guys, my bad. It's run, so I'm going to submit it. Yes, and my code's time complexity is big of log k, because we are removing the head and we are adding the leaf node to the head and checking from that node as tree. I will dry run it, and I will explain about the basics of queues and how are we going to implement it. Okay guys, let's meet in the dry run. Hello guys, let's start the dry run for the code. Now before proceeding to the dry run, let me show you the basics, what we need to focus on. So let me introduce about the heap data structure. Sorry, what is a heap? Heap is a complete binary tree. Okay, basically heap can be represented by a priority queue. Fine, and let me give an example for it. For the basics of how are we going to add or remove in a heap. Okay, like offer function, like in the above code, and the poll function as we used in the code. Okay, right. Okay, let me create an array with the values 10, 11, 12, 13, 14, and 7 and 9. Okay, so now I'm going to create a heap. By default, heap priority queue is a minimum heap. Can be both minimum or maximum based on which order you are specifying. Okay, now let's create an heap. 10, 11, 12, basically it's a tree data structure. 13, 14, and 7. Now when we are going to add 7, it is not satisfying the condition, you see, because the parent is greater than the child node, but it should not be like that. So in the adding in a queue, adding in a heap, we are going to change the position, like 10, 11, 12. Basically we are going to swap with this 12. Okay, sorry, 7 and 12, 13, 14, and once again this and this are not satisfying, so again 7, 11, 10, 12, and 13 and 14. Like the same, we are going to add 9. Again 7, 11, 10, 13, 14. Basically heap is very easy to implement when compared to trees. 9. Now again we are going to check for satisfying the condition. Again it is not satisfying, so we are going to swap 7, 11, 9, 13, 14, 12 and 10. Okay. Ah. Okay guys, I think this is satisfying the conditions. Now this is not sorted, right? So we are going to heapify. Basically we are going to remove the elements from it. So we are going to remove the head, that's the root node. Okay, now going for the remove function. We are going to remove the head. Okay, first I will write this 7, 11, 9, 13, 14, 12, 10. Okay. Now if you want to remove 7, okay, I will just draw this again. 7, 11, 9, 13, 14, 12, 10. First, when we are removing the element from the heap, we are going to remove 7 and then adding this value 10 to as the root, the last leaf node as the root. Okay. Now we are going to remove this. That's it. Now if we need to check if it is satisfying the minimum heap condition. No, it's not satisfying. So once again 9, like we should swap. Okay guys, be easy to follow. I think 13, 14 and 12. Yes. Now in a heap, okay, sorry, in a heap we are going to just uh, moving the root leaf node to the root, like swapping the element 10 with the 7 as we done before, and then checking for the condition to satisfy for it. Now this array structure becomes, guys, you can also use array list for easy, array list hash map for easy as yourself. It's not my, okay, 7 is removed, it's become 9, 11, 10, 13, 14 and then 12, and the part is called the heapified part. I am telling with my own names, so guys, 7, this is the sorted part. Okay, for your understanding. Now again, if we want to remove 9, this goes like, okay, now again we are adding the root node, leaf node 12 to the root, and then we are satisfying the conditions. No, it's not satisfying, so we are moving 10 and 12, swapping 10 and 12. Okay. 9 comes here. Okay guys, are you getting this? Now again we are going to do this 10 and then the leaf node 14 comes here, and I am going to remove this. Yes, removed, and then 10 comes here. Once again we are going to swap. Sorry guys, now we are going to check for the conditions. No, it's not satisfying, so once again moves 14 here and 11 here. Okay, now once again it is not satisfying, so 13 goes there, 14 goes there, right? Now let's remove 10. Sorry, let's remove 11. 14 goes there. Okay, and 11 comes here, and checking the conditions. No, it's not. So again we are going to remove this. Okay, checking the conditions. 14 goes there, 12 comes here. Okay, now again we are going to remove 12, and root node 14 goes there, 14 here, 12. And then once again we are going to remove 4. Now we are going to satisfy the conditions. No, it's not satisfying, so 13 and 14. Now again we are going to add 13, 14, like this. Okay, so this is how heap works basically, guys. I hope you are getting it, I think. Okay, now coming to the dry run. In this dry run, we know what a heap is, so we are given the kth value 3 and the array 4, 5, 8, 2. So we are going to create a heap. Okay, now again 4, we have just added 4, and again 5, satisfying conditions. Now when we are added 2, it is not satisfying, so we are going to swap again 4, 2, 8, 5. Now once again we are going to swap 2, 4, 8, 5. Okay, now we are going to remove the while condition. We are going to satisfy the while conditions. Size is greater than 3, obviously 4 nodes, right? So we are going to use remove the elements. Okay, now we are removing the 2 from here, and it becomes mentioning 2 from here, and 5 goes there, 4, 8. It's not satisfying the condition, guys, so I'm going to swap it once again 4, 5, 8. Okay, now this is the final heap that satisfies the condition. Now we are given add function in this. The add function is you to add elements in the p queue, which is priority queue in short. Okay, now once again we are going to add 3, 4, 4, 10, and so on. Okay, guys, that is the problem. Okay, we are going to add the elements in this queue, and we are just going to use a peek function to find the largest element. Okay, after many trials, like in the above add function. Okay, guys, thank you for watching this video. If you like this video, like and subscribe to my channel for more videos. Thank you.